We've learned about ionic compounds, and as you remember, an ionic compound, such as sodium chloride, consists of a metal and a nonmetal. And the metal forms cations, so when these are split apart, the metal forms a positively charged cation, and the nonmetal forms a negatively charged anion. These ionic compounds that we've been working with are often called binary ionic compounds. And the word binary refers to two. In other words, made of one cation and one anion. Another type of ionic compound is made of what we call a polyatomic ion. And the word polyatomic literally means many atoms. So a polyatomic ion is an ion made of many atoms. An example of a polyatomic ion would be CO3 as its formula with a -2 charge. And what you need to keep in mind is that in a polyatomic ion, these atoms are bound together and act as a single unit. So this is a single unit, and the -2 charge applies to the entire unit. You cannot change this formula or the subscripts. So you cannot change the formula or the subscripts in the polyatomic ion. It always stays the same. This is what we call the carbonate ion. How are you going to learn these? Well, you're just going to have to memorize them, and you already should have a list that is pasted into your lab notebook. And in class, I'm giving you tricks to help you learn some of those names and some of their charges. How do we make a compound or an ionic compound with a polyatomic ion? The rules still apply. The rules are the same as making an ionic compound with a cation and anion. Let's suppose what we want to combine calcium, which has a +2 charge, with our carbonate polyatomic ion. As you recall, in order to get the subscripts, we can apply the crisscross rule. So the charge on the cation becomes the subscript on the anion. And when you're adding a subscript to a polyatomic ion, you have to put parentheses around the whole polyatomic ion. And the number of the charge on the anion becomes the subscript on cation. So we end up with this formula. But if we take a look, we have two subscripts of 2. This can be simplified. Both are divisible by 2. The lowest whole number ratio is 1:1, not 2:2. So this simplifies to CaCO3, and we get rid of the subscripts. How do we name it? We simply name it by naming the cation, which is calcium, and the anion, which is carbonate. So the name of the compound is calcium carbonate. If I want to combine potassium, which has a +1 charge, with my carbonate polyatomic ion, and I apply the crisscross rule, the 1 becomes the subscript on the CO3, and as you recall, when we have a subscript of 1, we don't write it, and the 2 becomes a subscript on the potassium. So we end up with the formula K2CO3, and the name of this compound is potassium carbonate. For one more example, if I combine aluminum with a +3 charge with carbonate, which has a -2 charge, and I apply the crisscross rule, The 3 becomes a subscript on the carbonate. And remember, I need to put parentheses around the CO3 before I add the new subscript. And the 2 becomes a subscript on the aluminum. So I end up with the formula Al2CO3 parentheses 3. And the name of this compound is aluminum carbonate. So what's important to remember is that for the polyatomic ion, this acts as a single unit. You cannot change the formula or the subscripts ever. The CO3 always stays CO3. The entire unit has a -2 charge. This subscript is always a 3. It can't change. You can't add subscripts in here. You can't change them at all. You just need to pretend, essentially, that this is a single ion. Just like chloride is a single ion with a -1 charge, carbonate is a single ion with a -2 charge. Okay? They can combine to make ionic compounds, as we see here. So we'll take a look at some other examples. And I'm going to show you some other ions, polyatomic ions. This is the nitrate ion. It has a -1 charge. This is the sulfate ion. It has a -2 charge. This is the phosphate ion. It has a -3 charge. We are going to combine them with some cations. So we're going to combine them with sodium, which has a +1 charge, magnesium, which has a +2 charge, aluminum, which has a +3 charge. And let's try manganese, the +4 version of manganese. So we can set this up as a chart. And we did something similar in class. Oops. Okay. So now we're going to combine sodium with the nitrate. So we have sodium, +1 charge, nitrate, -1 charge. The charges balance. So the formula is simply NaNO3. And the name, I'll change colors here. Sodium nitrate. If I combine magnesium with nitrate, magnesium has a +2 charge, nitrate -1. We apply the crisscross rules. The 2 becomes the subscript on the nitrate. Remember, when you add a subscript to the polyatomic ion, you're putting parentheses around the entire ion. And the 1 here becomes the subscript on the magnesium, which we then don't need to write. So we end up with MgNO3 2. The name of the compound, magnesium nitrate. Sorry, I'm really squeezing this in here. Our next example, we're combining aluminum with nitrate. So the 3 on the aluminum becomes the subscript on the nitrate when we apply the crisscross rule. And the 1 becomes the subscript on the aluminum. So when we write our final formula, we end up with AlNO3 3. Again, remember, we're putting parentheses around the entire polyatomic ion before we add our subscript. And the name of the compound, aluminum nitrate. In our next example, we have manganese, which has a +4 charge, and nitrate, which has a -1 charge. Excuse me with changing colors here. I kind of lost track of what I was doing. So the 4 here becomes the subscript on the nitrate. And so we're adding parentheses. While the 1 on the nitrate becomes a subscript on the manganese. So we end up with MnNO3, 4. Now when we name this, remember that manganese is a transition metal and it has multiple charges. It has the charges +2, +4, +7. When we name compounds that have transition metals in them, we need to use a Roman numeral after the name to indicate the charge on that transition metal. So this is manganese 4 nitrate. Okay. So what I'd like you to do is on your own, write the formulas, combine these cations with the other 2 polyatomic ions, and I will name these for you. This is sulfate. This is phosphate. And I'll put nitrate's name up here. Remember when you're adding subscripts to the polyatomic ion, you are putting parentheses around the polyatomic ion before you add the subscripts. So what I'd like you to do is pause this tutorial and fill this in, and then come back and you can compare your work to mine. Okay, so now we're back and you can compare your work to mine. Here we have Na2SO4, sodium sulfate, MgSO4, magnesium sulfate. The +2 and the -2 charges cancel out. Al2SO4, 3, aluminum sulfate. And to get those subscripts, remember you apply the crisscross rule and put the polyatomic ion SO4 in parentheses before adding the subscript. For manganese 4 sulfate, in this example, I'll work this out for you here. Manganese has a +4 charge, sulfate has a -2 charge, and when we're applying the crisscross rule to this, this 4 becomes the subscript on the sulfate, and the 2 becomes the subscript on the manganese. And remember that we need to add parentheses around the sulfate before we add the subscripts. But these subscripts of 2 and 4 are not the lowest whole number ratio that we can have. Both of these are divisible by 2. So the 2 can be divided by 2 to become a 1. So manganese has a subscript of 1. The 4 can be divided by 2 to have a subscript of 2. So sulfate has a subscript of 2. So this formula, Mn2SO4, 4, simplifies to MnSO4, 2. Remember, in ionic compounds, subscripts have to have the lowest whole number ratios. Sodium phosphate is Na3PO4. For magnesium phosphate, again, you're applying the crisscross rule. So the 3 of the charge on the phosphate becomes a subscript on the magnesium, and the 2, which was the charge on the magnesium, becomes a subscript on the phosphate. In our next example, aluminum phosphate, the +3 and -3 charges on the aluminum and phosphate balance, so we don't need any subscripts. And our last example was manganese 4 phosphate. Again, we apply the crisscross rule to get the subscripts. There is one polyatomic ion that acts as a cation, and this is what we call the ammonium ion. It is cation. So we can combine the ammonium ion with any regular monatomic anion, such as chloride, and the charges on this would balance, and we end up with NH4Cl. This is ammonium chloride. Again, the same rules apply. The ammonium acts as a single unit. The entire unit has a +1 charge. We can also combine the ammonium ion with an anion that is a polyatomic ion. Let's say we combine it with sulfate, which has a -2 charge. So again, you're remembering that these polyatomic ions act as single units. we can apply the crisscross rule. The 1 becomes the charge on the sulfate, the 2 becomes the charge on the ammonium. So our formula is NH4. We need parentheses around it to put the subscript of 2 that's coming from here, SO4. And the sulfate just has a subscript of 1, so no parentheses are needed. The name of the compound is ammonium sulfate. So we do have one polyatomic ion that acts as a cation. And it can be combined with any anion, whether it's a single ion anion, which we call a monatomic anion, like chloride or fluoride or sulfide or oxide, or it can be combined with a polyatomic anion like sulfate or carbonate or phosphate. Okay, so this is our introduction to polyatomic ions. Remember that you do need to memorize these. If you don't, things are going to get really frustrating and confusing. So work on that memorization.